as we look at 15, we want to take a look at what were your two new equations. So if I'm looking at 15, my first equation in 15 I should have rewritten as y is equal to. First off, I'd subtract a negative 4x, and then I have to divide everything by negative 1. So when I subtract negative 4x, I would have originally had negative y equals negative 4x minus 1. But my new equation, because I'm going to divide by a negative 1, should have been 4x plus 1. Did you have that for your first equation?
Yes, I did.
Okay. When I look at the second equation for 15, so on your graph paper, I need these two equations. When I look at that second equation, you are adding x to both sides, and you should have had y equal 2x minus 5. Do you have that equation?
Yeah, I just didn't divide it by.
So you didn't have the 4x plus 1?
I did it on that one, but I didn't do it on.
The second one,
Yeah.
You shouldn't have divided. You should have just added the x and had y equal 2x minus 5.
Okay, I had negative 2x plus 5 equals negative y.
So when you have this y, anytime we're graphing, slope-intercept form, keeping in mind is when you have a positive 1y equals your slope mx plus b. So I would try graphing it that way and see if that works out for you. 19, let's take a look at writing your equation. And if you didn't graph, this is going to be a perfect one today for using our graphing calculator, and that's why we're not handing this assignment in. In 19, it says the number of right-handed students in math class is 9 times the number of left-handed. If we are thinking about that equation, what do you want to use for your variable for right-handed people? X or y? X? Or do you want to use y? Some of you use y, some of you use x. If I was using y, Georgia, what does my equation look like? Y equals 9 times x. 9 times the number of left-handed. So when I'm identifying this, one of the things in these questions, you might want to say x is equal to our left-hand people, right? And y in this case is our right. There's more right-handed people, right? 9 times the number of, so if there's like 3 left-handed people, there's 27 right-handed people, right? 9 times 3, okay? The second equation is going from this next sentence. The total number of students in class is 30. Well, if we only have left and right-handed people, the second equation, so this is our first one, the second equation is going to be x, left-handed people, plus the right-handed people equals 30. That's how many people are sitting in class. Okay, and then we will look at how we're going to get that answer. Now, if you were graphing this, you would have rewritten this one in slope-intercept form and had y equal negative x plus 30. That's a pretty big scale that you have to use. You have to go from 0 up to 30 on your y-axis, right, to get to that point. So that's a big graph, and so this is why graphing calculators, and even better, tomorrow we're going to start using substitution. That's why we use these other methods of solving, because graphing is not always nice and convenient. As you look at number 20, when we read that, it says in a nursery is growing a tree that starts at 3 feet tall and it grows an average rate of 1 foot a year. They have another tree that starts at 4 and it's growing at a rate of 0.5 per year. That 1 foot per year and 0.5 per year, what would you say that is in our equation up here? My slope or my y-intercept? The per year, this is definitely my slope for those two, okay? So these are my two slopes. So when I look at equation 1, I might say, oh, you know what, the height of tree 1, and you can either use y, because we're in graphing, y1, y1, we're talking about tree 1. What was happening in tree 1? It was growing 1 foot per year, 1x, and it started out at 3. If you don't have these equations down, make sure you have the equations on your paper for all of these. What do we know about the second tree? Well, the second tree started out at 4 feet tall, so y sub 2, and this tree is growing at a half a foot a year, so 0.5x plus 4. So I should have those two equations. So again, when I'm looking at your paper, I'm going to see you have these two equations. If you tried to graph them, awesome. If not, we're going to use our graphing calculator and do that today. Okay?
The last one, number 21 here, is we are looking at that one. If I look at my situation, members pay $20 fee plus $3 for aerobic classes. Non-members only pay $5 for each class. What is the total number of aerobic classes? So my aerobic classes, that might be my variable X. What would Y be? What is Y standing for in this problem? Anyone have any idea what we're looking at? What do you have? Not the cost, but how much what? How much do we have to, the Y is how much we have to pay, right? This is our dollars that we're paying to go to the class. So in the first one, we had to pay a $20 fee plus $3 a class. If X stands for our aerobic class, how can I write that equation? What is it going to look like? Raise your hand if we are looking at $20 fee up front and $3 for each aerobic class. You need to be thinking, what's my rate of change and what is my slope? Rate of change or slope, what is my starting or initial point? You want to tell me what they think they have for their equation? George, you have one?
Y equals 3x plus 20.
Y equals each aerobic class 3x plus 20. 20 is my initial fee, okay? If I only go to one class, I pay $23 to go to that one aerobic class. That is not a good deal unless I go to quite a few classes, right? Is it a good deal? So if I'm thinking of being a non-member and I just want to go take that aerobic class, what is that possibly going to look like, Sam? Y equals 5x, right? We just walk in the door. I want to take this class. They go, oh, you're not a member. You got to pay $5. If you're going to Quartz Plus or whatever your place is, you're not a member. You have to pay so much to be a part of that class or whatever they're doing. Okay, those are my two equations. So again, when I look at yours and we are working with the graphing calculator, this one's a little easier, but still, y-intercept of 20, right? This one is a y-intercept of 0. So we still have a pretty big graph if you are looking at that. Number 11, I'm not sure if just graphing it, if you're having a problem with number 11, please come in and see me as you're looking at that one. Oh, let's see, what else do we have? 9, 10, we didn't have to do 10, you were doing the odds, 11 to 37. 31. So if we're looking at 31. 31 says you're looking for a job after school. One job pays $9 an hour, another one pays $12 an hour. You must buy a uniform that costs $39. After how many hours of work would your net earnings be the same? Write an equation to model each situation. So the first one, we might think of Y as being our dollars that we're earning, right? And if we're doing it in slope intercept, X is how much we are paid per hour, right? So the first equation, what do I want to look at that one that you had? If I'm looking at that one, what do you think, Avery?
Y equals 9x.
9x.
I don't know.
First
That's
equation, that's it.
All right.
Okay? Kaylin, how about the next equation that we are making more money, but we had that initial fee? Y equals
12x minus 39.
12x minus 39. Again, ugly to graph this, right? Because we have to start at a y-intercept of negative 39. So again, this is going to be a great one today using our graphing calculator. That's why you're not handing it in. Make sure you have the equations down so that you can use the graphing calculator today to answer these questions. Or if you don't get time in class to get to all of them, then you can go to the Desmos and do that on there. Okay? The last part that you were looking at was, or that I see questions on, 57. They're just asking you to solve for y. 55, solving for y. The one with the decimals should be a little easier. If you're still having problems with that, make sure you come and see me. But this one in 55, you are subtracting 1/2 x from both sides of the equation. If you didn't do this one with us. you would have now had 1/3 times y is equal to a negative 1/2 x plus 5. I don't want to have 1/3 times y. I want 1y. Now you could have divided by 1/3, but that gets a little ugly. The easiest way to do that is to simply multiply by its reciprocal. And I want to do that by every single term. So as I do that, 1y is going to be equal to 3 times a negative 1/2 gives us negative 3 over 2x. And 3 times 5 gives us the plus 15. So keep this assignment out, and we're going to go to your notes. And as we are looking at your notes, on the graphing calculator, you're going to take your graphing calculator out so we can look at this. I will be pulling mine up also in class. So, Algebra 1 we use graphing calculator. You won't use it that much in geometry, a little bit next year, but then the following year again, in Algebra 2 you use it a lot. That Desmos calculator on your device is wonderful. It does a lot of these same things. But when you take the ACT test, which is the high school test that kind of figures out like how you're going to get your scholarships and all that kind of stuff, they usually will let you use a graphing calculator. They won't let you use a phone or a device or anything else. So in the high schools, they always have you do this because you have to use this right now on the graph or on when you take that test. So I just want you to hit the y equals key. That's way up here. So if you haven't turned yours on, the on button is way down here. Turn it on. And then hit this y equals key. That's the graph key. The variable key that you're going to be using is the second one in right here. So when we put in an x, this is the key we're going to use. And this is our one to graph a table. So if I am looking at your graphing calculator and you hit the y equals, yours looks a little different than mine, but if you have anything there, I want you to hit clear, and I want you to make sure that none of the equations have anything there. So there's probably 10 of them. Make sure that they're all cleared out, okay? And then go back up to the first one. Calculator from that y equals button. You will plug in 3x minus 7. So y equals, and I'm going to put 3. How do I get to the x? It's right next to this alpha key, x. Then I'm going to put minus. Now, if there's a negative number, like that next one, this is the negative button to put in a negative 0.5. But we're simply going to put minus 7. Before you hit the graph button over here, I want you to hit the zoom button. And if you hit zoom, we want it to be a standard graph. So hit zoom, and you can either arrow down or you can just type in 6 and hit enter. And you should get that equation. Okay? Hit the trace button right now, right next to the graph. Yours might have started you at a different point, and now use the right and left arrow keys, and you can see that it moves it along there. Those are all solutions to that equation, right? Okay. To get it to the home screen where you do the calculations, you always hit second. Notice you'll see an arrow, and then hit that mode button. You want to do me a favor and shut the door? If we are looking at that, I now want you to hit second, and I want you to hit y equals. And the reason some of your equations are not going in, possibly, 2 things. You might have some of the plots being on. So please make sure that you hit, when you hit second y equals, is everyone at this point? Then just hit 4 and hit enter. So this is when we plot statistics. We want that to say done, okay? We're going to go back to the y equals. And some of you are putting in that second equation, so you go down to 2. And the reason yours isn't working is you use a minus here. This is negative. You must use this negative button. So you're going to use negative down here. Then you're going to put in 0.5 and the x, and you're putting in plus 7. So if yours said error, dim mismatch, or error, because you probably use the minus here, and it should be negative. And now I get graph. And it graphed the first one. Oh, mine was a shading one. Yours was not. Okay. So when I go back here, I just need to change the way that my graph is. And we should have. So on the graphing calculators, you can kind of decide how you want the line to be. So that's where that might be a little different. So that when I look at my graph, I should see those two lines. Okay? Did everyone get theirs to work now? Okay. So next thing it says is, as you are looking in your notes, it says, okay, once you've plotted these, we want to go to and use this button. So the table set button. So you're looking at your graphing calculator, and you will notice that if we are looking at the table, what we want to do is up above, let's see which one are we looking at. Right above graph is table. Okay? So we are going to go second table. Now yours looks a little different than mine up here. It doesn't have like all these lines, but you have your X and you should have your Y1 and your Y2 behind it. Okay? Mine is going up by a scale of 1. Is yours also going up by 1s? So you can change that at different points by going to what's called your table set, but at this time, since ours is all this way, we're going to leave that. Okay? So where is the point of intersection? So I see at 0 with -7 and 7. I want to see when y is the same. So as I keep moving down this, when do I notice it's the same? I see the 2 5s, and it's when x is at what point? 4. So if I'm looking for a solution to this one, where these two are the same, I am looking at my solution being, if I was looking at this, what would my solution be? My solution is going to be 4, 5. How do we write it? Your answers, just like on your homework last night, all should have been ordered pairs. If you didn't write it as an ordered pair, and you put 4 and 5 without the parentheses, I automatically take a point off when we do that on the quiz. Okay? That is automatically one wrong because you did not tell me an ordered pair. You must have those parentheses. Let's go back to your graph. So hit the graph button. And I want to show you another way that you can find that point of intersection. So we could have done it by tracing, using that trace button, and moving. If I use my right and left arrow key, I'm going to get closer. And if I use the up and down key, that switches me between the lines. So this was our first equation. If I hit the up arrow, it switches me to the other line. If I hit the up arrow again, it switches me. So it switches back and forth. The up arrows, if you're on trace, will move you between your two lines. We're going to do even better than tracing and getting this answer, because if we look at this solution, we can get really close, but because these have all these little tiny pixels for your graph, we might not see exactly the 0.45, right? So it says 4.099, 5.2, which is pretty much if we are looking at that 4, 5. So hit the second button, and then hit the trace button. And it says, well, what do you want to calculate? And we want to calculate the intersection. So we're going to hit 5. So it was second, and then we hit the trace button, and now I'm going to put 5. And it says, oh, is this your first line? All it means is this, and if you use the right and left arrow key, it just means, is this your first line? You're going to get enter. And it says, is this your second line? Is this your second curve? Okay? So when you do that calculate, it should come up, is this your first one? You just hit enter. Is this a second line? Enter. And then it says, well, what do you want to guess? You do not even have to be close to the guess in order for it to work. And if you hit enter, it's going to tell you that point of intersection, which was 4, 5. Okay, we're going to do that again on the next one. So if you turn and look at your notes, we want to put this one in now, okay? So go back to your y equals, and we're going to put in those two equations. So you always have to be to y equals. You're going to clear the two equations that were, put in the new ones. So you are going to put in negative down at the bottom, 5x plus 6. We can tell our y-intercept is 6, has a negative slope. It's pretty steep if we are looking at that one. Compared to our second one has a slope of negative 1. You can just put negative x, and then you have your minus 2. And again, this time we're just going to graph those two right away. We don't have to use the zoom function. So when I am looking at those two graphs, it looks like my point of intersection is somewhere over here. It looks like if you were going to estimate it, where would you estimate it? x2, and then down how far? Down like maybe -3, -4. Let's check it doing that table. Second, and hit the graph button. Do you agree at x is 2? They both were the same. So our solution should be, if we are looking at that, 2, -4. Again, as you look at that graphing calculator, I want you to do the calculate. So I want everyone to do this one with me right now. Hit second. Make sure your team, your shoulder partner's at the same spot. Hit the table. Or trace, excuse me. Second and trace. We are getting the intersection. That's 5. Everyone at this point. It says, is this your first curve? Hit enter. It just means, is that your first line? Did you hit second and then hit trace? Now you're at intersect, choice 5. It says, is this your first line? Enter. Then it says, is this your second one? Notice it moved to the second line. Hit enter. It says, is this your guess? You can guess that point if you want. You can even guess way over here. The calculator is going to put it right at this point of intersection. You can get really close to it, but you don't have to. And it'll say, oh, they intersect at 2, -4, which is what we had here, 2, -4, okay? So, sometimes as we look at equations, it's nice to be able to write them this way. Now, this is where like the graphing calculator comes in kind of nice. But what I want you to do instead is I want to look at our equation that we had in number 19. The equations we had in number 19, right, was y equals 9x and y is equal to -x plus 30, was it? We're going to put those two equations in. So go back to your y equals, clear out the two equations that were there, and let's put in number 19. So the first equation was 9x, very steep. Second equation has just a -1 slope, so -x plus 30. Now, our standard graph is not going to probably show this solution. So you hit graph, and that's one line, and you can't even see the other one, right? Which makes sense, because my graph only went up to 10. What do we think we need our graph to go up to? At least what? 30. So we need to change the window. So what you're going to do is, this is the table set, but you're going to hit the window button. And it says your minimum for x, that means it went down to -10. We can leave that. What did we just say we want? Do we need to change our x maximum? Are we changing the x's or the y's? Y. So please arrow down till you get to y max. And we want to maybe put 35. Do we still need it maybe going up on y's by 1s? That's going to be a lot of tick marks, right? And we probably don't need it at -10. We can probably make this, and you have to use the negative button. Maybe we could use -1, right? So it's just a little below the or that x-axis. And we might want our scale to be 2s, or you could go 5s, right? We want to keep the x scale the same. And now hit graph. Now, my second line has dots instead of a line. But can we now see the point of intersection if we are looking at your two graphs? Do the second calculate and find that. Do the second calculate right now and find your point of intersection for that one. Please do that right now. Putting in these two equations, do second calculate and find that point of intersection. What did we get for an answer on that one? If we are looking at that, what did you get? We got 3 and 27, which makes sense, right? 3 times 9 is 27, and 27 plus 3 equals 30. So if we are thinking about that graph, that kind of makes sense, right? That's what we are going to be looking at when we look at those equations, okay? So, when you're doing the other ones, just so as you are looking at those, okay, that was my point of intersection, okay? Now, what I would like you to do is we are going to be putting these in your graphing calculator and looking at those solutions with your shoulder partner. So, I would like you to do this one and check with your shoulder partner. I'm going to put the answers up in just a minute. Try this one. And then what I really want you to do for the remainder of class is after you've done those two and I'll put the answers up, I want you to go back to yesterday's homework and the ones that we said, like those story problems, and put the graph in and do your work from there.